Hello, my name is Keshwani. This K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the math portion of the GRE. We have been solving math problems out of this book here, the official guide to the GRE, the revised journal test. If you do not own this book already, purchase one immediately. You're going to need it in order to prepare for the exam. The problem that we are about to solve is the one that you will find on page number 149. Today is our day number 36. Page 149. Let's turn to page 149. Yesterday, on day number 35, and if you have not watched yesterday's video, it's important that you do so. Just look for day 35. Just type in revised GRE math day 35 and it will pop right up. And watch the videos. Yesterday, we solved all the problems that you see there on page 149. I want to redo problem number 13, which deals with something called a notion called known as the normal distribution, something that did not appear in the old GRE. That's the reason why it's called revised GRE. The reason why it is called the revised GRE is because, believe it or not, because it has been revised. It's a new GRE, hence the revised GRE. In the old GRE, the book that I'm holding in my hand here, this concept of normal distribution did not appear. They never asked any questions about it. In the new GRE, they have been putting more emphasis on the concept of statistics. So that's what I want to cover in this video. It's going to be a brief introduction for those people who are not familiar with this concept. You don't have to sit there and to pick up some thick statistics book of statistics or take a course, one semester long course to know all that you need to know for the GRE, because what they ask you in the GRE about the normal distribution is a very basic concepts, very fundamental concept. We'll cover them in 10 minutes here. Okay? So here we go. The only probability distribution, this is called a probability distribution. The reason why it's called probability distribution is because that's what it shows. It shows different probability, the odds of something happening. So in a normal distribution, or for that matter, any probability distribution, what you have on the y-axis, are the frequencies. Y-axis tells you how often something happens, and here are your observations. For example, if I see 3 observations of 10 and 4 observations of say 15. I'm trying to make one up. 10 and 15, 4 observations, and then I see 5 observations of say 20, and I see 6 observations of say 25, and so forth. These are as you can see, these are frequencies. 3, 4, 5, 6. These are frequencies that tells us how often we saw something. And if you were to join all of these things, it begins to take the shape what is known as a normal distribution. The reason why it's called normal distribution is because it's very symmetric. Whatever you see on this side, this is your mean. This is the mean or the average. Mean right here, this line here. And whatever that happens on the left hand side, the same frequencies are replicated on the right hand side. That's all. So for example, here I saw 3 observations right here, 3 observations of 10,000 right here. That tells me that I should also see 3 observations of whatever it was here. This was 4, this was 5, so this was 3. This is 25, or whatever happens to be here. It's going to be the same observations here. So if this is 25 and this is 20, this is 30, and this is 20, this is 15, so this is 35, and this is 10, so this must be 40. So voila, there you go. So if we saw 3 observations of 10,000 then we should also see, which is 15, watch here, this mean here happens to be, let me rewrite it nicely. This was 25, and these are observations. And this on the y-axis tells us how often it happens. So I'm going to use my pen here so that my finger does not get in the way. So this is the mean here is 25. If the mean is 25 and we saw 3 observation of 10, which is 15,000 below the 25, then I should also see 3 observation 15,000 above 25, which is the mean. 15,000 plus 25,000 is 40,000 right here. So you see, three observations of 40,000 and 3 observations of 10,000. Here we have 4 observations of 15,000. Think of this as income. So these observations are income levels. Let's make it very simple. So what I did was I took a survey. I took a survey of my town. I went around every household in the town and I asked them, what is your household income? What is the household income? And I found that 3 households told me that they have a yearly income of 10,000. 4 households told me that they have yearly income of 15,000. 5 households told me that they have a yearly income of 20,000. And 6 households told me that they have yearly income of 25,000. And then again, the story is repeated. 3 observations told me that they have a yearly income of 40,000. The 40,000 is 15 away from this thing, which is same as this thing. It's very symmetric, and so on and so forth. 5 households told me that they have yearly income of 30,000. And 4 households told me that they have yearly income of 35,000. And when I plotted this, so here are the frequencies, and here are the observation, and when we join the points, it comes out to be a very symmetric graph, what is known as a normal distribution. How spread out the normal distribution is measured by what is known as standard deviation. Now you don't need to worry about how to actually calculate standard deviation. It does appear in the exam. There are usually 1 or 2 questions on the whole exam, maybe 1 question, that's it, which will require you to calculate the standard deviation or something. Don't worry about it. If you're not shooting for a perfect 800 score on a GRE, don't worry about it, okay? Just keep it very simple. Just understand the basic concepts. So I'm going to redraw this thing here on a freehand. Oh, this is the problem from this is the graph that you see from the previous problem, the problem that we were actually doing, on page number 149. If you turn to it, there in that on page 149, they were asking us what is going to be the observation if the mean happens to be 8 and if the standard deviation happens to be 2.5. What is going to be the observation that is 2 standard deviation away from the mean? Well, observation that is going to be 1 standard deviation away from the mean is going to be, standard deviation here is 2.5. So it's going to be, this is 8 plus 2.5, which is this one. And the observation that is going to be 2 standard deviation away from the mean is going to be your mean, which is your 8 plus 2 times 2.5. 2 times 2.5 is 5. 5 plus 8 is 13, so this observation is 13. Standard deviation tells you how spread out the observations are. So I'm going to redraw this thing. I want to keep this thing here. Let's arrange this part here. And I'm going to show you 3 scenarios where it will drive the point home that the greater the standard deviation, I'm going to read it one more time. The standard deviation tells us how spread out the observations are. The greater the standard deviation, the more spread out the observations are. The smaller the standard deviation, more clustered the observations are around the mean. So let's take a look at first one here. Here's your mean, and here's my first observation. As you can see, it's very clustered, it's very close to each other, very small standard deviation because, well, we'll get to this in a second here. Here's the second scenario. See here that here the observations are more spread out, and we can show the third scenario where the observations are going to be extremely spread out. I need the room again. Let's erase this part, we don't need it anymore. I'm going to show you another scenario where we have a very wide spread out scenario. Voila. Here the standard deviation is going to be very large, and what the standard deviation tells you is that within the first standard deviation, this is 1 standard deviation below the mean, and this is one standard deviation above the mean. And within the first standard deviation, within the first range of first standard deviation, one standard deviation below the mean and one standard deviation above the mean, we capture 68% of the population, 68% of the observation. And if you don't want to remember 68%, keep it very simple, keep your life very simple. 2/3, think of this as a 2/3. 1/3 of the 1/3 of the observations are going to be from the mean to one standard deviation below it, within this range here. Right here. This is your 1/3 of all the observations, and this is 1/3 of other observations. And that is true about any standard deviation, which is why it's called standard deviation. Standard normal distribution is so called because it has these characteristics, where if the mean household income in the town, listen carefully, if the mean household income in the town happens to be 25,000, this is a different example, not the previous example that we did before, because I don't remember what the mean was there, I erased it. If this mean standard deviation, mean household income in a given town is 25,000, and if I tell you that the standard deviation is $20,000, that tells me, listen carefully, that tells me 20,000, 25 plus 20 is 45,000, and 25 plus, this was a silly example because we cannot have a negative income, because by the time we get to second standard deviation, it's going to be 20 times 20, which is 40. We can't have negative income. Of course, to be very technical, to be very pedantic, and if you don't know what that means, we'll learn this in a second. To be very technical, there are millions of households with negative income because their subsistence is on, they live on welfare benefits. The government provides them checks where they have no income and they get money from the government. So that, if you want to think of that as a negative income, but let's not get into nitty-gritty. Let's make it 10,000. So what this tells us is 10,000 minus 15,000 is 15. 25,000 is 15,000. So what this tells us is this. What it tells us is that in this village, in this town, I did the survey and I found out that the average household income is 25,000, and I found out the standard deviation was 10,000. How we figured out the standard deviation, let's don't worry about it right now. We're not required to know that for the GRE. Based on those facts, standard deviation of 10,000 and a mean of 25,000, that tells us that 2/3 of the household in this town, will have the income somewhere between 15,000 and, this should not say 10,000, this should say 10 plus 25 and 35,000. $10,000 above the mean and $10,000 below the mean. Within this range, you will capture 68% of the population. And because it is symmetric, half of 68 is 34, and this is 34. That's why this is approximate. Or to be more precise, this is also approximate, but that doesn't matter. What happens by the time you get to second standard deviation? By the time you have gone to second standard deviation, you will capture another 14% here and another 14% here. Let's see what that works out to be. So here we have 34%. Then we have 14%, 34% from the mean to the first standard deviation, another 14% from the mean to the second standard deviation. So that's 8, and this is 4, that's 48. What you're left there is virtually nothing, only 2%, is left in the tail. That's what this dish, we like to call it, tail. Only 2% of the observation right here. I'm going to emphasize it by putting it right here. This is your tail. Only 2% of the population is left in this tail, and only 2% of the population is left in this tail. 2% plus 2% is 4%, which means virtually everything. By the time this is the essence of it. This is the gist of the whole thing. This is the nub of the whole discussion. And if you do not know nub, we'll learn that in a second also. By the time we get to the 2 standard deviation, we have captured virtually everybody. 98% of the observations are captured within the 2 standard deviation. And that's what it tells us. Finally, to get this thing out of my system here, let's learn these 2 words. The word pedantic, which means to be overly scholarly, to show off your scholarly knowledge, if you will. Pedantic. I'm trying to look here the day when we learned it. Or did we learn it? I'm looking at my list here. I can't find it. Maybe I did cover it, maybe I did not. I cannot find which day we covered it. But that's what it means. So to be pedantic means to show off, to be ostentatious in your display of knowledge or learning, if you will. So that's what I was saying. This is how I use in the context. If you remember it, what I was saying is that inadvertently before I had put down, instead of $10,000, I had put down the standard deviation of $20,000, and had the standard deviation be $20,000. Then by the time you get from here to here, 20,000 minus 25,000 minus 20,000, you're left to 5,000. Another 20,000, you're left with negative 15,000. Well, the question is, can a household have an income of negative 5, whatever it was, negative 15,000? And to be pedantic, if you want to be very technical, if you want to be very nerdy, you could argue that if you receive an income in a welfare income, that's a negative income. But anyway, let's learn this word nub so I can close this thing off because it's been going on for a while. NUB nub, which is something that you will learn in day number 11. The reason I was able to find the nub very quickly as opposed to pedantic is because there aren't too many words that in the dictionary that I've covered starting with letter N. There are many words starting with letter P. I couldn't find pedantic. Nub is the word. Just type in Keshwani Prep dash vocab. Just type in Keshwani Prep dash vocab dash day 11. Or vocabulary day 11, and you will find this word. The nub of something means the gist of something, the essence of something. So the nub of the whole discussion, the essence, the gist of the whole thing is that by the time you get to 2 standard deviation, you captured virtually all the observations. In other words, virtually entire household in this village, in the context of this problem. If you subtract another 10,000 from it, you get down to 5,000. If you add another 10,000 to it, you get 45,000. So what it means in this example, listen carefully, what this means in this example is that we did the survey in this village and we found out that the average household income was 25,000. We also found out that the standard deviation here was 10,000. Let's make a note here. The standard deviation in this example was 10,000. What that tells us is that virtually all the household in this village, 96% of the households in this village will have a household income somewhere between 5,000 and 45,000. If the standard deviation turns out to be 10,000. Because the first standard deviation captures 2/3 of the observations, but by the time you get the second standard deviation, you pick up another 14% on this side, another 14% on that side. That's all. That's all you need to know. Oh, one last thing that I want to talk about before we call it a day, about the normal distribution. I need the room. So I need to raise this thing here. And by the time you have understood everything in this video, that's all you need to know, as I said, for the GRE. That's basically it. So, since on the y-axis we are measuring frequencies, and here are our observations, which observation happens most frequently? The one that happens most frequently is the one right here, which is also your mean. But what do we call an observation that appears most frequently? The observation that appears most frequently is called mode. If I have a whole bunch of numbers here, 3, 4, 5, 6, 5, 6, 7, 7, 7, in these observations, the number that appears most often is 7. So the mode of this observation is 7. Here, whatever this observation is, which is the mean, is the one that happens most often in a normal distribution. Therefore, in a normal distribution, mean and the mode are the same. The mode equals the mean. Whatever number that appears most frequently is your mean, because that is the peak of the bell curve. Let's talk about one more observation, one more concept, which is the median. Median means half the observations are above it. I'm just going to talk about it. Median means half the observations are above it, above the mean, and half the above that number, and half the observations are below that number. For example, here we have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers here. Had there been odd number of numbers, let's add one more here. 2, 3, 4, 5, 5, 6, 7, 7, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since there are 9 observations, the mode is where 4 observations are going to be below the number and 4 observations are going to be above that number. 1, 2, 3, 4. This is your mode. 1, 2, 3, 4. You see? Now, if we did not have 2 here, and if it just says 3, 4, 5, 5, 3, 4, 5, 5, 6, 7, 7, 7, there are 8 numbers here. Since there are even number of numbers as opposed to odd number of numbers, the way we figure out the way we figure out the median is we go 1, 2, 3, 4, which is this guy right here, and then 1, 2, 3, 4, obviously this guy here. What falls between 5 and 6? What falls between 5 and 6 is 5.5, and that's your mode. Mode is where half the numbers fall below it and half the numbers fall above it. But that happens right here. This is where, because of the fact that it's symmetric, in the normal distribution, let's make a note here somewhere. In normal distribution, mean is same as mode and is same as median. There is no distinction between the 3 concepts. They are all the same. That's because of the fact, as I keep repeating like a parrot, that's because of the fact that it is very symmetric. That's all. I'm done here because otherwise we can keep on going. I wanted to make a 5 minutes, 10 minutes video. I think it's very long now. I will see you tomorrow. Hopefully you got something out of it. I'll see you tomorrow on day number 37. Alright? Bye now.